Okay, Wildcats, today we're looking at journal page 32, finding rational solutions of polynomial equations. Steps to find the rational zeros of polynomial functions. Step 1, use the rational zero theorem to find all possible rational zeros. Step 2, use a synthetic division to test the possible zeros to find the zero of the polynomial function. Step 3, factor the polynomial. Step 4, find the remaining zeros. Okay. All right, journal page 32. Finding rational solutions of polynomial equations. Example 1. Find the rational zeros of the polynomial function, then enter the function in factored form. Okay? All right. So first off, let's put a 1 here, 1 here. Okay? Now, what you have to do for rational zero theorem is you need to find m and n. Now, m are all the numbers that divide into -8. Okay? Well, those numbers are plus or minus 1, plus or minus 2, plus or minus 3 doesn't work because 3 doesn't divide into 8. 4 works, plus or minus 4. 5 doesn't work because 5 doesn't divide into 8. And then 6 doesn't work, 7, and then the last one is 8 because 8 divides into 8. Okay? Now the n values are all the numbers divided into 1. Well, that's easy. It's just plus or minus 1. Now you need to do m divided by n. Okay? Well, 1 divided by 1 is plus or minus 1. 2 divided by 1 is plus or minus 2. 4 divided by 1 is plus or minus 4. And 8 divided by 1 is plus or minus 8. Now, these are all the possible zeros of the polynomial equation. Okay? All right? So now we're going to use synthetic division and test each of these to find which one works. So we'll start with a 1. Okay? And then we bring down the numbers for synthetic division. 1, -1, -10, -8. Okay? Now, if this is a 0, when we do synthetic division, we'll get a remainder of 0. If it's not a remainder of 0, then it's not a 0. So bring down to 1. 1 times 1 is 1. -1 and 1 is 0. 1 times 0 is 0. Bring down to -10. 1 times -10 is -10. Remainder is -18. Okay? Since your remainder is not 0, 1 is not a 0 of the polynomial function or equation. Okay? So now let's try -1. Let's just go in order. Okay, so 1, -1, -10, -8. Okay, bring down the 1. -1 times 1 is -1. -1 and -1 is -2. -1 times -2 is a positive 2. -10 and 2 is -8. -1 and -8 is a positive 8. The remainder is 0, so we can say that x equals -1 is one of the zeros. Okay? All right, so now the next step is we're going to factor. Now this was 1x cubed, x squared, x, but when you divide, the exponents decrease by 1. So this is now 1x squared minus 2x minus 8, and we're going to set that equal to 0. And we're going to factor. So we know if you factor, this should be 2 parentheses because x squared, 2 parentheses. Okay? Equal to 0. Now, we know that x times x gives us x squared. Okay? Now we need to find all the combinations that multiply to give us -8 combined to be -2. Okay? All right, well, let's try 1 times -8 is -8. 1 minus 8 is -7. That's not -2, so this combination doesn't work. So now let's try 2. 2 times -4 is -8. 2 minus 4 is -2. So they multiply to give -8. They combine to be -2. These are our factors. So x plus 2, x minus 4. Okay, so now we set them equal to 0 and solve. So x plus 2 equal to 0 and x minus 4 equal to 0. So we subtract 2 from both sides. So x equals -2. Okay, add 4 to both sides. So x equals 4. Now, we know since this was x cubed, there should be 3 zeros. The highest exponent tells you how many zeros there are, okay? So our zeros are x equals -2, x equals -1, and x equals 4. Now, what we can do is use Desmos to graph example 1 to verify that these are in fact the correct zeros. So let's do that now. Okay, so let's graph example 1. So x cubed minus x squared minus 10x minus 8. Okay, so when we click here, there's our -2, there's our -1, and there's our 4. Okay, do that again. And so that verifies that our zeros are correct. All right, so go ahead and finish up example 1. All right, now let's take a look at example 2. Okay, now finding journal page 32, finding rational solutions of polynomial equations. Example 2, find the rational zeros of the polynomial function, then enter the function in factored form. Okay, so first we need to find the m and the n. Okay, so the m are all the factors of -12, which we know are plus or minus 1, plus or minus 2, plus or minus 3, and these are all numbers that divide into -12. Plus or minus 4, plus or minus 5 doesn't work because it doesn't divide into 12. Plus or minus 6, 7 doesn't work, 8, 9, 10, 11. The last one is plus or minus 12. Now the n value are all the numbers that divide into 1, which is only plus or minus 1. Now we need to do m divided by n. Well, that's easy. 1 divided by 1 is plus or minus 1, plus or minus 2. Basically, when you divide all of these by 1, it's just 2, 3, 4, 6, and 12. So plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. And again, because 1 divided by 1 is 1, 2 divided by 1 is 2, 3 divided by 1 is 3, 4 divided by 1 is 4, 6 divided by 1 is 6, 12 divided by 1 is 12. Now, one of these is a possible zero of the polynomial function. So again, we're going to test synthetic division to find it. Okay, so we'll start with a 1. So then 1, 1, because that's a 1 right there, -8, -12. Okay. Okay, so bring down the 1. 1 times 1 is 1. 1 and 1 is 2. 1 times 2 is 2. -6, when you combine, 1 and -6 is -6. That combines to be -18. The remainder is -18. 1 is not a 0. So now let's try -1. 1, 1, -8, -12. Okay, so bring down the 1. -1 and 1 is -1, 0, 0, -8. And -1 times -8 is a positive 8. Remainder is -4. So -1 is not a 0. Okay, so now let's try positive 2. So 1, 1, -8, -12. Okay. So bring down the 1. 2 times 1 is 2. 1 and 2 is 3. 2 times 3 is 6. -8 and 6 is -2. 2 times -2 is -4. Remainder is -16. 2 is not a 0 of the polynomial function. Okay, so now let's try -2. Okay, so bring down the 1, 1, -8, -12. Okay, so bring down the 1. -2 times 1 is -2. 1 and -2 is -1. -2 times -1 is a positive 2. -8 and 2 is -6. -2 times -6 is a positive 12. The remainder is 0, so we know that x equals -2 is a 0. Okay, All right. Now, we know that this was x cubed, x squared, x. And when you divide, the exponents decrease by 1. So now this is 1x squared minus 1x minus 6, and we'll set that equal to 0. Which brings us to our next step. We're going to factor. Okay. Now to factor this, we know it's x squared, so 2 parentheses. Now we know that x times x makes x squared. Now we need to find all the combinations that multiply to give you negative 6 and combine to be negative 1. Okay, so it's 1 times negative 6 is negative 6. 1 minus 6 is negative 5. That doesn't work. Okay, so now let's try 2 times negative 3 is negative 6. 2 minus 3 is negative 1. Okay, so we have our negative 6, we have a negative 1, so our factors are x plus 2, x minus 3. So set x plus 2 equal to 0, x minus 3 equal to 0. So we subtract 2 from both sides, x equals negative 2. And we add 3 to both sides, so x equals 3. So our zeros are negative 2, and 3, which makes sense because this tells us how many zeros there are. This says there's 3. We have 3. Okay, so now let's graph and verify that, okay? So we graph, that's x cubed plus x squared minus 8x minus 12. Okay, we click here. It verifies our negative 2. We click here. That verifies our 3. Okay. All right, so finish up example 2. All right, now let's take a look at example 3. Okay. Journal page 32. Finding rational solutions of polynomial equations. Example 3. Find the rational zeros of the polynomial function, then enter the function in the factored form. Okay, so we need to find m divided by n. Okay, which we need to find all of the m values first. So that's all the factors of 210. So plus or minus 1, plus or minus 2, plus or minus 3. 4 doesn't work, plus or minus 5. Now, we can keep going all the way till we get plus or minus 210. But really, you don't need to go that far unless these don't work. If none of these work, then you keep going to get all the factors all the way up to 210. Okay? Now, 1 is just plus or minus 1. So now we do m divided by n, okay, which 1 divided by 1 is plus or minus 1, 2 divided by 1 is plus or minus 2, 3 divided by 1 is plus or minus 3, 5 divided by 1 is plus or minus 5, 210 divided by 1 is plus or minus 210. Okay, so now let's test 1. Okay, so we bring down the 1, negative 210, negative 1, 210. Okay, so bring down the 1. 1 times 1 is 1, which negative 210 and 1 is negative 209. 1 times negative 209 is negative 209. This combines to be negative 210. 1 times negative 210 is negative 210. So the remainder is 0. That's what I mean. You don't have to go through all the factors because, in fact, we found it with just 1. Okay, so we know x equals 1 is a 0. Okay, so now we factor this was x cubed, this was x squared, this was x. Okay, so now we know that this is 1x squared minus 209 x minus 210. equals 0. Now we factor. We know 2 parentheses equals 0. We know that x times x makes x squared. Now we need to find all the combinations that multiply to give you negative 210 and combine to be negative 209. Well, let's start with 1. 1 times negative 210 is negative 210. 1 minus 210 is negative 209. So we have our factors, x plus 1 and x minus 210. Okay, so we said x plus 1 equal to 0 and x minus 210 equal to 0. Subtract 1 from both sides, x equals negative 1. Add 210 to both sides, so x equals 210. So our zeros are 1, negative 1, and 210. So let's graph and verify that those are correct, okay? Okay. Now, x cubed minus 210x squared minus x plus 210. And then there's our negative 1. There is our 1. And if we zoom out, keep going, keep going. Oh, you can see it. There's our 210. Okay. That verifies that those are correct. I heard the bell, so let's go ahead and finish up the last two examples. All right. Now, for example 4, you see that this function has gotten very long and it looks very complicated. If that happens, what you can do is go straight to Desmos and graph it. So let's go ahead and graph example 4. So x to the 4th minus 4x cubed plus 3x squared plus 4x minus 4. Now, we know this is going to be 4 zeros. I'm going to press home to get this back to here. And watch. Ta-da! 1, 2, 3. Okay. So our solutions are x equals negative 1, x equals 2, and x equals 1. Okay. Okay. All right. So go ahead and finish up example 4. All right, example 5. Okay. It says find the rational zeros of the polynomial function, then enter the function in factored form. Okay. Now this one's unique in that we can actually factor it because of x fourth. Now this is a unique factoring, and let me show you what I mean. To make x fourth, it's going to be 2 parentheses, set equal to 0. We know that x squared times x squared makes x to the 4th. Okay. And now all we need to do is find all the numbers that multiply to give you positive 4 and combine to be negative 5. So let's try negative 1 times negative 4 is positive 4. Okay. And we know that negative 1 minus 4 equals negative 5. So that works. We have our 4 and negative 5. So our factors are x squared minus 1 and x squared minus 4. Okay. So now we set these equal to 0. X squared minus 1 equal to 0. X squared minus 4 equal to 0. So we add 1 to both sides. So x squared equals 1. Take the square root of both sides. Now remember, square root's plus or minus. So x equals plus or minus 1. Now add 4 to both sides. So x squared equals 4. Take the square root of both sides. Remember, square root is plus or minus. So x equals plus or minus 2. So your answers are x equals 1, x equals negative 1, x equals 2, and x equals negative 2. Okay? I'll just put one big box over it around them. Okay? Now, you can actually graph this to verify that. So let's do that. Okay? So let's graph x to the 4th minus 5x squared plus 4. And let's check. Negative 2, good. Negative 1, 1, and 2. And let's do it again. And there you go. There are your solutions. They all check out. Go ahead and finish up your examples and have a wonderful Wildcat